All right, our second lesson for chapter 1, we're going to talk about measurements of segments and angles. We're going to get some new vocabulary, and we're going to do some review of some vocabulary that we've done before. We're going to really talk about these things called congruency. So when we have congruent segments and angles and what that means, we're going to talk about the different types of angles by their size, and then we're going to start using those angles by finding some angles in a clock problem, which is one of our favorites. You're going to love them, I promise. So that's what 1.2 is all about. So let's get started. So the first ones here, this should be review. I'm hoping that you guys remember what these different types of angles are all about. So if you can, you could pause your video, write down what you remember about these 4 types of angles. You could always just check using those little audio clues, or you can watch the video if you don't remember them, but then take a peek on what we write down for sure. Okay, so our first one is called an acute angle. So an acute angle is any angle that is less than 90 degrees. Okay, now in this class, we don't talk about any negative angle measures. You can save that for Algebra 2 and beyond. So it's any angle that's less than 90 degrees, but it's also greater than 0. So there isn't going to ever be an angle in this class that will be a negative angle measure. So I'm going to put that in parentheses. So when we just say less than 90, we really mean less than 90 but greater than 0. But you're never going to see something that's less than 0. Okay? All right, so a right angle is an angle that equals 90 degrees exactly. So hopefully you remember that. That's a pretty easy one, pretty straightforward. So if it equals 90 degrees exactly, we can put this little box in the corner, right? So that little box that shows up in the corner of an angle tells you that it is 90 degrees. This is a right angle for sure. So that's the little symbol we use for a right angle. Okay, an obtuse angle is any angle that is greater than 90 degrees. Okay, so it would look something like this, right? But similar to our acute angle, in this class, we don't really talk about anything called a reflex angle. So if we're thinking of like this angle around here, well, that's greater than 90 degrees. That's what's called a reflex angle, and we don't talk about those at all in this class. Again, save that for Algebra 2 and beyond. So when we say greater than 90 degrees, we also mean less than 180 degrees. Okay, so we don't ever go more than that straight line, right? Nothing more than that. So greater than 90, but less than 180. But you don't really have to say the less than 180, because in this class, we're always only going to be talking about angles that are less than 180 degrees. All right, so then our last option is our straight angle, and a straight angle is an angle that equals 180 degrees exactly. So it looks like a line, right? But really, any line could be considered a straight angle, and we know that when we can think of it as an angle, that angle measure is 180 degrees. All right, so hopefully you knew those, right? Have little sketches. Pictures are worth 1,000 words, right? So a little sketch here saying this is this angle, this one is this, angle. If you want to, we can say, okay, here's our straight angle is the one going across here. So those are the different types of angles based off of their measure. Now, take a look at just these first 2 angles here over on the left, angle G and angle S. How would you describe them? Yeah, you probably would say that these 2 angles are acute. Okay, they're less than 90 degrees. Yeah. But you might also say that they have the same measure, right? They're both 42 degrees. Interesting. Okay. Well, how would you describe these 2 segments? We can't say they're acute or obtuse or straight. Those are segments, not angles, right? So you probably would notice, though, hey, these are both 10. So these have the same measure. Now, in geometry, we have a very special word that we use when we have 2 things that have the same measure, and we use it a lot. This word is called congruent. So two things are congruent if they have the same measure. All right, so I'm just going to write this down, have the same measure. But what I want you to do, you could write that, right? And we do have a symbol for congruent. There's a symbol that means congruent. And that symbol looks like this. It's an equal sign with a little squiggly above it. So this is the symbol for congruent. All right, so you probably want to have that written down, but then what I want you to do is I want you to write this special sentence, and it will make sense later. I want you to write it like this. If two angles have the same measure, then they are congruent. Okay. Now, the reason I want you to write this and put a box around it, put a star next to it or something, is we're going to need to write things in this form, this if-then form, for some interesting things called proofs coming up later on in this chapter. And so this is one that you're going to actually use quite a bit in your proofs, and I want you to be able to have it in your notes somewhere to come back and look at. Now, we said if two angles have the same measure, but as we just saw, it could be angles or it could be segments, right? So that word angles could be replaced with the word segments if we wanted to, right? And we'll talk about later on about how we switch the order and all of that. But that's the idea is behind congruent. If two angles have the same measure, then they're congruent. If two segments have the same measure, then they are congruent. Now, we do have special ways of marking things congruent. Now, this is also important because we are going to be marking our pictures like crazy. So, it says 42 degrees in the angle measures, but if I didn't have a number there, if I just was told that angle G is congruent to angle S, we would write it in a way that would look like this. Actually, here, let's get this. It would say angle G is congruent to angle S. That's how we would use that symbol for congruent. And we could mark our picture by putting a little arc. I'm going to get rid of these for now. Right? I put a little arc in the actual angle part of it. Now, if these two arcs are exactly the same, that means that they are congruent. If I have two arcs in one and only one arc in the other, that means they're not. So I would always want to mark them exactly the same. So you can put two arcs and two arcs. You could put an arc and a slash. You could put two arcs and a slash, something like that. But they have to be marked exactly the same so that and that's how we know that they would be congruent. Whenever two angles have that same arc through the angle part of it, and it's the same, that's when we know they're congruent. Same thing over here with our segments, right? Now I can't put any arcs around these because it's just a straight line, right? So what we do is we put a little dash on each of the lines. So if they both have the same dashes, that means that they're congruent. You could do one dash, you could do two, right? Something like this. And that indicates that you have congruent segments. So dashes on the segments, arcs through the angles, they have to have the same marking to be showing that they are congruent. Okay. Here's the next slide here shows you all the different options, right? So all of these different markings are showing that they are congruent. So this first one is showing that the angles are congruent, right? Notice they both have one arc. Now it does look like it's kind of colored in. They don't usually have to be colored in, just have the arc. The next one is showing that these segments are congruent. Right? They have the double in both, right? That's showing that they're congruent. Now over here in the triangles, they marked a whole ton of stuff. So this is showing, I see angle A up here has one arc and angle D also has one arc. So it's showing that angle D is congruent to angle A, or angle A congruent to angle D, either way. I see angle B has two arcs. Angle E has two arcs, so that's angle B is congruent to angle E. I see that C has three marks and F has three marks, so that means angle C is congruent to angle F. So I have all these different pairs of angles, but it's also showing us something about the segments. But I love this picture because it shows you the difference between marking angles congruent and marking segments congruent. So if I see here this segment AC has 1 dash, oh, and segment DF, oh, sorry, DF is also 1 dash. So that's telling me that segment AC is congruent to segment DF. Notice how I'm using those segment symbols and the congruent symbol. That's kind of the idea here, okay? I see 2 dashes on segment AB, 2 dashes on segment DE, so that means that segment AB is congruent to DE. And then finally, I see 3 dashes down here, BC or CB and FE. So CB, segment CB is congruent to segment FE. So all those symbols, look at that, like that's a whole ton of stuff, but we instantly got all of that information just by how it's marked. You don't always have to write all that stuff out. I was just showing you kind of how those symbols can convey a whole bunch of information very, very quickly. So this is what we mean by marking your pictures. When you see things that are congruent, we make sure that they have the tick marks that line them up. All right, so we kind of talked about our congruent, we talked about our angle measures. So now what we're going to do is actually find some angle measures here, right? So I have a clock. Now these are clock problems. We just love these clock problems. They're just a fun way to do different angle measures and use some math along the way rather than just here's an angle, measure it with a protractor, right? So we actually calculate some angle measures. So here it says that it is 9:20, and you can see on the clock 9:20, and I want to figure out the angle formed by the hands of the clock, right? Now remember, we only think of angles that are less than 180 degrees. So we're always talking about this smaller angle. We're never talking about the larger one that goes around the outside, like not this angle, nope. Okay, it's always the smaller angle that we're talking about with these angle formed by the hands of the clock, okay? Always the smaller angle. So I need to figure out what is this angle measure between the two hands. Now notice when I have 9:20 here, the long hand, the minute hand is pointing directly at the 4, right? It's lining up exactly. But this hour hand is a little bit past the 9, right? Now here, I have all these tick marks and maybe I can kind of tell, but it's sort of hard to tell how far past the 9 it really is. And that is gonna come into play. But you know, that hour hand slowly moves between the 9 and the 10 as our minute hand goes around, right? The more the minute hand goes, the closer that hour hand is gonna get to the 10 o'clock and the farther away it's gonna get from the 9. So really think of those hands moving around the clock and which direction they go. So to start off with, we really have to think of degrees, right? So do you know how many degrees are in a whole circle? If we went all the way around, that would be 360 degrees. Now I notice these numbers, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They're breaking that whole circle into 12 sections. So to figure it out, I would say, okay, well, 360 divided by 12 would mean that each one of these sections is 30 degrees. So this is 30 degrees, and this is 30 degrees, and this is 30 degrees, right? So the 360 is the whole circle, and that circle is divided into 12 sections. So each of those sections between the numbers is exactly 30 degrees. So if I look at this angle that I want, let's see, this angle that I want, well, this covers all of these full sections, right? 4 to 5, 5 to 6, 6 to 7, 7 to 8, and 8 to 9. All of those full sections, 1, 2, 3, 4, 5 full sections. So I have 5 sections that are each 30 degrees. But that's not it. Then I also have this little bit, right? this little bit, sorry, here we go, right here, that little nugget that's after the 9, but before the 10. Now, if I went the whole thing, like this whole section would be 30 degrees, but I only want this little part of it, right? Just this bit. And it's going to here. So I want this part between the 9 and that hour hand. So if I think about, it takes that hour hand 60 minutes to go from the 9 to the 10, right? Right now, it is 9:20. It takes 60 minutes, so it takes 20 minutes. It's gone 20 minutes past, right? And there are 40 minutes left because it takes 60 minutes to get the whole way. And I've gone 20 minutes to get to where the hand is right now. So I need to figure out that fraction of 60. Well, that fraction, here, I should probably put this part in a different color. Okay. Because this whole thing, right, is 60 minutes, and I've gone 20. So that fraction is going to be the 20 minutes that I've gone past the 9 out of the 60 minutes total that it would take to get to the 10. That's the fraction of that section, and that section is 30 degrees. So I want just the 20 minutes, right, because that's the direction the hand moves. The hand moves around the clock in this direction, right? So it's gone 20 minutes so far out of the 60 minutes it would take to get between the 9 and the 10 o'clock. And that whole section is worth 30 degrees. So this is the trickiest part, is figuring out that fraction. Okay, now I just need to actually multiply it up. So 5 times 30 gives me 150 degrees from here. 20 over 60 times 30, I'm going to do a little canceling here, right? This is really like 30 over 1. So this will cancel, and this will give me a 2. So 20 divided by 2 is 10. So I've got 150 plus 10, which gives me 160 degrees. Now just do a little self-check here. Does this look like it's an obtuse angle? Sure does, 160 degrees. In fact, it's pushing the straight line. It's really close, right? So 160 degrees definitely makes sense for the angle that that clock is making. All right, I really colored that up there, but we were slowly going through the process. So let's try another one here to see if you kind of got the idea. So again, we're finding the angle of the hands of the clock, so always the smaller angle. So this is the one we're talking about. All right, now I notice that my minute hand is directly at the 3 for 11:15. My hour hand is a little bit past the 11, right? Not sure how much, but it's a little bit past. So remember, every section is worth 30 degrees. So how many full sections do I have? I'm going to use some easier colors to kind of see. So I have, here's 1 full section, 2 full sections, 3 full sections, right? 1, 2, 3. So I have 3 full sections times my 30 degrees. Now I need to figure out that fraction of the section times the 30 degrees, right? What's that going to be? So we're talking about this part. Whoa, I grabbed the wrong color. There we go. This part right here. Okay, now think about how that hand goes around the clock, right? Here's the 11. It's moving this way around the clock, right? So since it's 11:15, this amount is 15 minutes. And that's to get to the hand, right? That's where the hand is. And then this would be 45 minutes before it'll get to the 12, because that whole section is 60 minutes. It's gone 15 minutes past, right? So it took 15 minutes to get to where it is. That means there's 45 minutes left before it'll get to the 12. Now, which one of these sections do I want this time? I want this section, right? That's the part that I want in order to be included in my angle. That's the side. So my fraction out of 60 would be the 45 minutes this time. And it all just depends on the way the hand moves around the clock. I probably should have put my arrows going this way, right? This is the fraction I want. All right. So you can see the two different ways, right? It just depends on where your angle is. On this one, it was the part of that section that was, past the 9 o'clock. On this one, it's the part of that section that's before 12 o'clock, right? How many minutes left before 12? That's the section I need because of where the angle is, all right? There is no trick. There is no way to figure that out without drawing the picture. You have to draw the picture. You just have to figure out which side of the section do I want in my angle this time. All right, so 3 times 30 is 90. 45 over 60, let's see, well, I'm going to again do a little cross canceling. This will be 2. 45 divided by 2 gives me 22.5. So that means I would have a final answer of 112.5 degrees, or 112 and a half would be perfectly fine as well.